We conducted a demonstration over 2015 and 2016, which looked at the value of growing an annual legume prior to wheat. Annual legumes can fix a lot of nitrogen from the atmosphere, but when grown for grain, much of that nitrogen is removed with harvest. Grain legumes are typically providing a nitrogen benefit of only about 15 pounds per acre. Much of that nitrogen is released late the following year, which can give a protein boost to cereals, which is good for wheat, but not so great for malt barley. Agronomists don't usually adjust their nitrogen recommendations by much, if at all, for wheat following a grain legume. But there is often a benefit to growing a cereal on legume stubble that goes beyond what can be attributed to the 15 pounds of nitrogen. This is called the rotational benefit of legumes, which includes improved physical, chemical, and biological characteristics of the soil. So we set out in 2015 to demonstrate the impact of canola, faba beans, soybeans, and peas grown prior to a wheat crop. This picture beside me shows the blocks of each crop established. They were replicated 4 times. In 2016, each of those blocks was divided into 5 plots and seeded to spring wheat with increasing rates of nitrogen. The rates were 0, 50, 80, 100, and 120 pounds per acre of actual nitrogen. This example is wheat on canola stubble. You can see with increasing nitrogen the crop becomes darker and there are more tillers producing heads. I kind of feel like Bobby Brady for some reason. So on July 19th, 2015, this is what the crops looked like. The canola had to be reseeded due to frost and flea beetles. The faba beans and peas recovered nicely from the frost, and the soybeans emerged from the ground a couple of days after the frost, so were unaffected. Canola and soybeans yielded well, and the peas did better than I thought. They weren't very vegetative, but they had seed. The faba beans yielded lower than I had hoped for. Faba beans really liked the moisture, and 2015 started out dry. I would also say that the trial site area was a droughtier part of the field. So the return over variable expenses using Saskatchewan Agriculture's crop planner depended on what year you'd looked at. Projections for 2014 through to 2017 were fairly stable for canola, and canola averaged about $190 per acre return. Returns were higher for soybean, but as you know, soybeans are a long season crop that come with an added risk. Pea returns were the lowest and fairly variable. The projections for faba beans were $8.40 a bushel in 2016 and then dropped to $3.60 in 2017. This, of course, makes a huge difference to profitability. I'm using Saskatchewan Agricultural's price projections, and I don't know if these values make sense, so if they don't, plug in your own values. Moving on to the wheat grown the following year. We found no significant interactions between main effects for any of the parameters measured. This means the effect of increasing nitrogen on wheat emergence, lodging, yield, grain protein, and fusarium damaged kernels was the same regardless of what the preceding crop was. So, technically, we only need to look at the main effects in this table. The value provided for the impact of the previous crop on wheat is averaged over all nitrogen rates. Likewise, the value for a particular rate of nitrogen is averaged over all preceding crops. So, what can we conclude from this table? Firstly, there is about a 15 bushel per acre yield response to applied nitrogen. The yield was maximized around 80 to 100 pounds of applied nitrogen, regardless of the previous crop grown. The other thing to mention here is that wheat yields are not increased by growing on a legume stubble. Statistically, there are no differences, and numerically, wheat is yielding more on canola stubble. So, unlike past research, we didn't see a yield benefit from growing wheat on a legume stubble. However, like past research, there was a higher grain protein associated with wheat grown on legume stubble. Grain protein of wheat continued to increase all the way to 120 pounds per acre of actual N for all of the stubble types. This figure is for those of you who still insist on seeing the wheat response curve for each stubble type. As I've stated before, these response curves are statistically the same, and they all max out at around 80 to 100 pounds per acre of applied nitrogen. Numerically, canola, which is the blue line, is higher, so there's no yield benefit from growing wheat on a legume stubble in this study. The grain protein response to added nitrogen is statistically the same between the stubble types. However, canola, again the blue line, is numerically lower, which is consistent with past research. So let's go back to the main effects table and look at some other significant differences. Not surprisingly, lodging was increased with increasing nitrogen rate. However, the level of lodging was greater on soybean and pea stubble. Perhaps this is an indication of more nitrogen coming available from these residues. Interestingly, the level of fusarium damaged kernels in the wheat grain increased as nitrogen rate increased. I think I have an explanation for this. Remember this slide? You can see increasing nitrogen rates are increasing the number of tillers producing heads. Tillers tend to flower later than main stem heads. As a result, I believe increasing nitrogen rates likely delayed and extended the flowering period and in turn the period over which the wheat heads were susceptible to infection. The whole trial was sprayed with Prosaro, but was staged based on the majority of the crop. So if anything, this would have disadvantaged the earlier flowering wheat in the 0N treatment. Unfortunately, this observation is not going to translate well into a useful recommendation. After all, which would you rather have? At 100 pounds of nitrogen, you can have a 51 bushel per acre wheat crop with 15.2% protein and 0.39% fusarium damaged kernels. You can lower the fusarium damaged kernels to 0.22% by applying no nitrogen, but now you have a 36 bushel wheat crop and only 12% protein. So, in conclusion, wheat grown on legume stubble tended to have more protein than wheat grown on canola stubble. Wheat yields were not higher on legume stubble compared to canola stubble. In fact, we observed the opposite. This is contrary to past research. The response of wheat yield and grain protein was the same to added nitrogen, regardless of the previous crop grown. You don't need to adjust your N recommendation significantly following a legume crop. Economically, it was best to grow either canola or soybeans prior to the wheat. However, soybeans are a long season crop, making them riskier to produce. Fusarium infection increased with increasing nitrogen. This is interesting, but not overly useful. So there you have it, the legume rotation trial with wheat. I'd like to thank Adopt for supporting this project.